So we have our ledge, and it was 1.6 meters, right?
Yep.
We have a ball, and it's leaving the ledge with only horizontal speed. So it doesn't have any upward speed or any downward speed. It's just going straight off the ledge horizontally. But we know that once gravity starts acting on it, that horizontal speed, it's going to bring it forward, but gravity is going to bring it down. So it's going to give us this nice parabolic trajectory. It'll land right here. And how far did it say it went?
20 meters.
20 meters. Cool. So it covered 20 meters of distance in some amount of time. If we knew what amount of time it was in the air for, then we could say, well, horizontal velocity would just be, we would use this equation. We would say x equals x naught plus v naught t plus 1/2 a t squared. That's the long version, but we know that acceleration in the horizontal dimension is 0, so that goes away. X naught, we pretty much always say is 0, so that goes away. So really we could say x, which is 20, equals v naught times our time. So if we can just get time, then we can solve for v naught, which is what the question's asking for.
Right.
So in order to get time, we need to look at what's going on in the y-axis, because we know that it's starting 1.6 meters above the ground. So we need to ask ourselves, how long does something fall for if it falls from a height of 1.6 meters? And to answer that, we can just use our kinematic equations. We can actually use this same equation, but the y version. So we would say y equals y naught plus v naught t plus 1/2 at squared. So we know that y final is 0. Y naught is that 1.6 meters that it was originally raised. V naught is 0, right? Because all of its speed was horizontal, so its speed in the y dimension was 0 initially. So if that's 0, it doesn't matter what t is, that whole thing just goes to 0, so we'll skip that. Plus 1/2 a in that y dimension, there is a value, unlike the x dimension, which is 0. In the y dimension, it's negative 9.8 or 9.81 t squared. So now we've got an equation with just one variable, and it's the variable that we want. So we can solve for t. Is this what you guys had done?
I just like made a rectangle.
Oh, did you?
I didn't really know how to get started, so.
Yeah, right triangles are always good in physics, but you got to be
Yeah.
careful about making sure they're the right triangles. So we end up with negative 6.505 equals t squared. So because it's squared, we're kind of just going to ignore this negative so that we can take the square root of it. And we get 2.55 seconds equals time. So now we've got time. We can come over here, plug it in for t. So we know 20 equals v naught times 2.55. Divide that over to get v naught by itself. And we get 7.8 meters per second. Is that the answer?
No.
It's not?
No, it's 35 meters per second.
So where was my mistake? 1.6 meters. That's right? 1.6 meters?
Yeah, that is right. Yeah.
1/2 at squared Oh, I see. Yeah, I did this wrong here. So the first thing we do is we get that 1.6 over to the other side.
Mm-hmm.
So we'd have negative 1.6 equals 1/2 negative 9.81 t squared. We can combine these two terms and we get negative
4.9.
4.905.
Mm-hmm.
So then we add that over because it's negative, so that's where I messed up.
That's what I did there when I got negative 6.5. Oh, you
No, 'cause you
added
add it.
Okay.
Yeah, I
I
see.
added it together. Okay.
So add 4.905.
Okay. So 3.
Yeah, so we end up with 3.305 if we want to be precise, equals t squared. We square root that. We get 1.8 equals t. Oops, just t. So then that's this number here.
It's
11.11.
35. 12 is, it says the answer is A. 35. Like even the answers we've been getting aren't anything.
Yeah, they're not in there.
here.
20 meters. Okay. So x equals x naught plus v naught t. So that's right. 20 meters. Over here we said y final is 0, y initial is 1.6 plus 1/2 at squared. It does seem like a lot of time though for it to be in the air if we only, so 1.6 meters is like here. If I was to drop that marker, it wouldn't take 2 seconds to hit the ground. So if we combine these two terms, we get negative 1.6 equals negative 4.905 t squared. To get the t squared by itself, we divide.
I tried that though and it didn't give me the right answer still.
It wasn't working?
So negative.
So if we divide both of these,
Negative 1.6 divided by negative 4 point. It gives me 0.3.
so
Yeah, it gives me like
1.6.
But wouldn't that be good? So then divide that by 20.
Well, first you have to square root it.
Yeah,
Oh,
it
yeah.
does square rooting it.
So then you'd get 0.57
7. Divide by 20.
equals
That
t.
should give you a higher number
Yeah.
than 20.
Yep.
That's the answer?
That's crazy,
Yeah.
because I was thinking that in
So 20 divide 0.57. So we get 35. And that's the correct answer.
Yeah.
So 35 meters per second equals v naught. Cool, so be careful with your algebra. That was a really dumb mistake. That makes sense though?
Yeah.
Yeah.
I used the wrong equation from the beginning. That's why I got crazy answers.
Makes sense.
Any equation, so.
So yeah, you try to make a right triangle here, just
Yeah.
straight like that.
Yeah.
So yeah, a lot of people do that. It is really tempting because, I mean, you see like two components of a
Yeah.
right triangle and you're like, oh, it makes sense. But yeah, you just have to keep in mind that that's an approximation,
Mm-hmm.
but it's not going to be the same as this curved path because, I mean, this is a straight line, this is a curved
Yeah.
path. So you could use it to, do quick approximations, but It's not going to come out to be the same.